So the formula of concentration was concentration is equals to the amount of solute divided by the amount of solvent divided by the amount of solvent. So here we will derive one equation. I'll be telling you later, but here, as we all know, concentration is represented by the concentration of hydrogen, right? So amount of solute, what was the solute? That is a smaller quantity, that is a one molecule that ionizes. So what will be the amount of solute? That will be the one, right? And what will be the amount of solvent? That is a larger quantity, that is a 1 million molecules. So we will write here 1 million molecules. So we can also write like this, like 1 into 10 power minus 7. When we will shift it into the numerator, so it will convert it into the minus. So we can also write like this. So here, after that, here we were having the H concentration before. Now we will discuss the OH concentration. Same formula we will apply here. 1 molecule of the solute and the 1 million molecule of the solvent. It will be the same. We can also write like 10 power 7. When we shift it to the numerator, it will convert into minus. So concentration of OH will be the 1 into 10 power minus 7. So this is the concentration of OH. And what was the concentration of H? That was the same, 1 into 10 power minus 7. Now we will derive one equation that is known as a KW derivation. That is known as a KW derivation. It is we can say included in the ionization of water. So we are having one formula, that is a Kc is equal to the concentration of products divided by the concentration of reactants So here, if we talk about Kc, the concentration of product, what was the product? We were having the one equation, that was the H2O. One molecule was ionized, that was H plus plus OH. This was the one molecule, right? So what was the product? That was H plus or OH negative. We will write like OH and H. This is the product, right? Now what is the concentration of the reactant? That was the H2O, right? This is the reactant and this is a product. So here when we shift H2O here, it will be like, we can write like H2O is equal to the, like this. So here Kw is basically the ionic product of water. Kw is basically the ionic product of water. Ionic product of water. We were doing derivation of the Kw, that was the ionic product of water. So in this, Kw was equals to the H plus and OH molecules. So the Kw will be equal to, what was the concentration of Kw? Instead of Kc H2O, we will write Kw. Instead of Kc H2O, we will write Kw. So here this will come. So what was the concentration of H? We have written here, that is this one, 1 into 10 power minus 7. So here we will write 1 into 10 power minus 7. And what is the concentration of OH? That is same, 1 into 10 power minus 7. So here it will be like this. Kw is equals to the 1 into 10 is power minus 14, right? 7 into 7, that will be the 7 into 2, that will be the 14. So here kW is equals to the 10 is power minus, we can also write like this, so that we can say kW, this is a ionic product of water. We can say that if the decrease or increase in amount of water at 25 degrees centigrade, kW remains constant. What? In decrease or increase in amount of water at 25 centigrade, kW remains constant. But change in temperature, but if we change the temperature, that is 25 degree, so kW can change. So kW can change. Here if we put the temperature 25 degrees centigrade, we will get the constant value of kW, that is 10 is power minus 14. 10 is power minus 14, right? If we change the temperature, we will get the different value of kW. But in decrease or increase in amount of water, kW remains constant. It will remain constant. It cannot change in decrease or increase in amount of the water. So that was all about the ionic product of water.